energy. Let's go, go, plug in eco energy. Go, let go. Go, that eco energy. You know.
Welcome back to another edition of Plugged In with Eco Energy. I'm Joe Bianchi, and I'm joined by my son Conrad. We're here at Eco Energy Services in the Chicago suburbs, and we actually have had a couple of great podcasts lately, and we want to continue on the circuit here. Last week we talked about 200 amp upgrades and do we need one actually, and what that might look like cost-wise and everything. So if you missed that, definitely go back and take a look at that episode. But right now, I want to start with a real situation that we see all the time. A homeowner calls us because they just bought an electric vehicle and want to install a charger in their garage. It's a pretty straightforward request.
It happens every single day here.
So come out, take a look. The homeowner walks us down to the basement, opens up the electrical panel, and immediately we can see this is going to be more complicated than we expected.
Yep. Say we open up the panel, which we do pretty often, and we find a 100 amp service that's completely full, no open spots for a breaker. And, you know, that right off the bat is not a good sign,
No.
But it can get worse from there.
100%. Yeah, and then we start tracing the wiring.
And some of the wire are great. They're in conduit, they're THHN, copper, and all that is awesome. But on occasion, you know, you'll see some aluminum wires in there. And then in another part of the house, there's some knob and tube wiring,
Right.
which hasn't been used from, the 50s?
Oh, well, it predates the 50s.
Wow.
Yeah, for sure. Probably back into the 40s, 80, 90 years ago. That's when that was used.
Wow.
But we see it active and live on the regular.
Yeah.
So Chicago homes were multi-generational electrical systems were installed. They didn't always tear out the old generation before they installed the new generation. So the homeowner wants to add on possibly the largest electrical draw item, whether that's an EV charger, whether that's a hot tub, whether that's a new stove that they're adding in, or a warmer. They just don't realize all of the impact that has on their existing system. So I guess that leaves us at a point of like delivering some really bad news. And
Right.
We hate delivering bad news, but we also hate worse that a really big problem we could be not mentioning, and then they have to face that in the most inopportune way. So one of the biggest things we look at in identifying wiring means and methods in older homes, and Conrad brought this up, was looking at, you know, like what year the panel was from. That tells us a lot about when it was last upgraded. We also look and we can see inside that panel, typically knob and tube isn't brought all the way into the panel. Mm-hmm. They have usually transitioned that. So oftentimes we get a call from an insulator or from somebody who's doing work up in an attic. Oh, we found live knob and tube wiring, and we need to know how to get around that. So we'll talk about those different wiring methods more specifically. But you've got homes that were built when?
In the 1940s, the 1950s, I mean, some date back as early as the 20s. And a lot of those homes have, especially ones that were in the 20s through 50s, have 60 amp services.
Oh, yeah.
And we kind of talked about that a little bit last week of when do you need to upgrade? You know, what do you actually have? A 60, 100, 200, maybe you have a 400.
Right.
And
what's interesting, though, is what I've seen, especially in our programs where we go and we help people out get their systems upgraded. Just because you have knob and tube wiring in the walls doesn't necessarily mean that we need to like tear open all of the plaster and lath and start from there. We've done dozens and dozens of projects where the homes are we're able to get up in the attic and run conduit from the basement up to the attic, and then distribute from either the attic or the basement onto the main floor, eliminating all of the knob and tube, the live knob and tube. And so that's not the end of the world, right? We can get around that. But these are things to be worried about. So start off with the knob and tube wiring. Homes that were built between 1880 through the 1940s. This is the most common type of wiring that was done. This is when a home was built. They literally had like a radio, a few lights,
Yep.
a couple convenience outlets. They were definitely designed for small electric loads.
Yeah.
And as long as additional load isn't introduced to that, those wires will likely outlast the person living there, you know? So they might have had a refrigerator, might not. They had ice boxes then where they had ice delivered. But then today, what are we looking at putting in there?
I mean, we have EV chargers. We've got electric dryers. Every house has air conditioning.
Yes.
We've got heat pumps that are starting to take over from gas furnaces.
Yes.
We've got induction stoves and even some more kitchen appliances like a heating drawer, like we've talked about, that can be a really big electric draw that people don't necessarily think of when
Right.
they have the idea to put one of those in. A lot of homeowners are really surprised when they find out that parts of their house still run on wiring that's 80 to 100 years old.
Yeah, absolutely. A lot of times, oftentimes, it's hidden from them during home inspection times where people have masked it or tried to hide knob and tube wiring or tried to hide old aluminum wiring. That's another big one. Let's talk about aluminum wiring for a little bit.
Yeah. Aluminum wiring can be a really big problem that, again, most people don't know that they even have or that it's a problem.
Right.
It was used a lot in the mid-1960s and mid-1970s when the copper prices were extremely high. People were looking for an alternative to
I
that
can see
copper
how
wire.
young you are because you say 1960s and 1970s. We call it the 60s and 70s. And that wasn't that long ago, okay?
Yeah.
Yeah, but copper prices spiked,
Yep.
causing...
In an attempt to bring the price of building a house down, a lot
Yeah.
of builders switched to aluminum branch wiring.
Right.
And that was an approved method back then.
Absolutely,
There was nothing that they knew was wrong with it. But what can happen is copper expands at a very different rate than aluminum. And
Right.
aluminum expands a lot more than copper. So as wires go through the heat cycles that they maybe weren't going through back then when houses had a lot smaller electrical loads, that aluminum wire is expanding and contracting and expanding and contracting, and that causes problems because the terminations eventually fail and the wire isn't rated to the same amps and all
Okay,
sorts
so-
of stuff like that.
From firsthand experience, I'll tell you my situation with aluminum wiring. What most people don't know is when aluminum wire arcs, it actually melts portion of the wire and catches the other part of the wire on fire, sending literally like flaming shards all over the place. And if it arcs against the ground, you'll get like a mini explosion with fire, little balls of fire that extend out, and it has caused an unbelievable amount of home fires.
Yeah.
Oftentimes, this is caused by homeowners replacing outlets. If you have an outlet that you need to be replaced, okay, the grounding plug broke or the faceplate cracked, and they change out the outlet, but they don't get the right outlet. If you have aluminum wire, you have to use an aluminum rated outlet. And nowadays they come rated for aluminum or copper. It's an ALCU rating that will be stamped right on the outlet itself. Most of the outlets that you're going to buy at Home Depot, Lowe's, Menards, they are not ALCU rated. They're only copper rated. So a homeowner unexpectedly swaps out an outlet that's not rated for aluminum. The expansion and contraction occurs on that outlet on the terminal where it heats up. Next thing you know, you have a little arcing event, and then you have your house fire.
And here's another one that I've seen be a problem with aluminum wires on the EV charger side.
Okay.
So let's say that you have a 100 amp service, right?
Yeah.
And you have all copper branch circuits. So everything past the breaker box is all copper wire.
Okay.
You'd think that that's fine, right?
Yeah.
What happens is sometimes those feeder wires that are your main wires from the utility coming in
Yeah.
are aluminum.
Right.
And because that EV charger is such a big draw, it can heat up and expand that aluminum, and then it contracts back and it changes the connection that's
Right.
made at the top of the panel.
Yeah.
And over time, that can heat up and cause fires.
Thermal expansion and contraction cause those screws to kind of back out, and next thing you know, you have a little arcing event. And aluminum does not bode well with that. So it doesn't necessarily mean that your house has to be rewired, but it means that we have to check and make sure that the outlets that were installed, everything from the outlets that were installed to the wire nuts that were used to connect the aluminum to copper wire, they're all rated for that because they have that built-in expansion contraction. They have a way of handling that issue.
Yeah, exactly.
So, where are we moving on to next? Panel limitations. Okay. When people call us about EV chargers, what's the first thing we check?
The electrical panel capacity.
Yep.
And a lot of common panel sizes, I know we went over in the last episode and a little earlier today, pre-1950s, most panels were 60 amp panels. From 1950 to 1970, that changed a little bit, and the home builders were putting in more 100 amp
Well,
panels.
what changed was this.
Exactly, yeah.
Is here we have my latest and greatest. I got the 2026 the National Electric Code that was delivered promptly this morning in 2026. Most municipalities won't adopt this code for at least 3 years.
Oh yeah.
More likely 6 or 7 years. But what we like to do is when we get our new code books, we like to see, okay, what are the changes? What are we looking forward to? Post EVs, there was no code about EV chargers.
Right.
Pre-solar panels, there was nothing in the code about solar panels. So as technology develops, as things change, the code adapts itself every 3 years. It's on a 3-year cycle. So we got 26, the previous one was 23, then we had a 2020, then we had a 2017, 2014, going back. Now, what you indicated here was pre-1950, we had a 60 amp panel, which is in line. And I believe the 60 amp panel was the minimum standard that you had to have for all the way up until I think maybe 2008 code or somewhere around there.
Right.
But at some point in time, they adopted it and made the minimum panel size 100 amps to serve a residence.
Yep.
Right. And then, still today it is 100 amps. That is the minimum size. But once you do your household calculations, it drives it up to 200 amps most of the time.
Exactly. And the builders started to see that electrical load was more of a thing, especially when the ACs come around.
Oh,
is
yeah.
really what kicked it up.
That's
from
30,
that
40
60.
amps right there.
Exactly.
Immediately.
And that's where we went from the 60 to the 100.
Right.
And then as we add EV chargers, heat pumps, electric dryers, all the things like that, modern homes, almost all of them come with the 200 amp service.
Correct. Yeah.
But 77% of the homes in America are still running on 100 amps.
100 amp service.
Yeah.
Right. And now we're seeing, with the electrification of everything, we touched on this a little bit last week. You use electricity to wash your clothes. You use electricity to cook your food. You use electricity to basically do almost everything that you used to do manually. And now those demands are much higher. We got EV chargers at 40 to 50 amps. We got heat pumps at 30 to 60 amps. Induction ranges are 40 or 50 amps. Electric dryers, 30 amps.
And suddenly that 100 amp panel is over capacity.
Yeah, 100% full, right. So you talked about last week, in order to really accurately size up a panel, we're looking to do a load calculation. And that is part of the code.
Yep.
That says we need to calculate this and that for this and this and that for that, and it's a complicated math equation that takes actually weeks to learn, and it takes months to master. But your local electrician, will know how to do that, and if they don't, then they missed a few weeks of classes.
But electrification isn't just about adding equipment, right? It's much more about the managing of the electrical capacity you have of the entire home,
Right.
and making sure that that stays within a safe range.
Right.
And that's really what we're going after here. What surprises homeowners the most when they start upgrading their electrical system?
I think code upgrades. I think that's the biggest surprise when we go to a home and they think their panels were, well, I mean, you flip the switch on, the lights come on, everything's working, I'm good. But you actually start to unravel some of those real problems. Like we can go back to early Romex, which didn't have a ground wire.
Yep.
Knob and tube didn't have a ground wire. Then you got more modern Romex, which is aluminum Romex, which has its own list of problems. We also have bonding issues that we see frequently.
Yeah.
Most of the time, the water heater was changed out. Well, a water heater is not an electrician, so the plumber is not an electrician, so the plumber doesn't know anything about bonding. And why would you need to put a copper wire from one copper pipe to another? They don't understand AFCI breakers. Code now says, and I want to say it's starting in 2008, where every single outlet in your house has to be AFCI or GFCI protected. You got meter socket issues. You've got age. You got damage to wiring. You've got cloth wires. You got we want to see surge protection on the homes. We talked about that before. And oftentimes older homes lack those things, and even more basic stuff they lack.
Yeah. Yeah, absolutely. When you open the panel, like we were talking about at first, when you walk in and you open the panel, sometimes you are pulling, like you're pulling a thread out on a sweater. It can unravel very quickly, but it's so important to figure that out and to make sure that your system is safe.
I think grounding was another big issue that we talked about before. That ground rod after 20, 25 years literally rots out in the ground.
Yeah.
And then you have no effective path for lightning to take should you get struck by lightning. Just that in and of itself, you should have somebody out there take a look at your system, verify that your ground has 25 ohms to ground, and things like that. You can it's something that an electrician should be able to check.
Yeah.
So all this stuff, none of it comes free.
No, unfortunately not.
Here's the bad news, guys.
The range of a service upgrade, should that need to happen, if we were to just do a panel replacement,
right,
and say a little bit more work, maybe we're driving a ground rod to make sure we're back up to code,
cleaning up some double taps on the
exactly.
Double tap, let's talk about what that means, because I don't know what we have.
I don't think we have. But a double tap is where you have a breaker, right? You have a bunch of them in your panel. And say there are 2 wires connected to that breaker. Very, very few breakers on the market are rated for that. And what happens is when you have 2 wires heating up and expanding, then that connection is going to be weak, like you talked about earlier with the arcing across the lugs. So those can cause problems. Very important to, again, have an electrician out, take a look at it, and they can determine if you truly need something. And that brings us into another thing we talked about, which is in our area, we know a lot of electricians.
Yeah.
And how many of them would you say are out to upcharge you over something they don't need to do?
Yeah, by and large, most of the electricians that we find are very honest and reputable people. I talk positively about my competitors. We're very friendly competitors. There's more than enough work. We have a shortage of electricians.
Yep.
So nobody's really trying to make any more work for themselves. We're doing our best just to keep up with the incoming calls.
Yeah, exactly.
So what is it going to cost me to have just a panel replaced? We're talking 100 amp panel to 100 amp panel. No actual upgrade. Just bring the system modern. Get new breakers, because after 30 years of a breaker in a position, it's likely not going to trip when it's supposed to.
Yeah.
And there's where your problems start. So panel replacement, talk to me.
Ballpark estimate, I'd say 3,000 to 6,000 would be a good range to get a panel swapped out. A little bit of light work, maybe we have to drive a new ground rod, stuff like that.
I in all fairness, I do think it's probably close to that 3,000 mark in most cases.
In most cases, I would agree. No, if we're talking about a service upgrade,
Correct.
which is what most people opt for when they're looking at that, because you're saying, hey, I have a 100 amp panel, but I'm looking at adding an EV charger, a heat pump, a gas, or an electric dryer.
And that's honestly when most people want to upgrade their panel.
Exactly.
Is when they're adding load onto their existing service.
Yep.
Yeah.
And that can range quite a bit depending on, stuff. But as a general range, say you're going 100 amp to 200 amp, nothing crazy. You're maybe 5,000 to 7,000. And if there's a lot of extra work, you might be pushing it a little higher.
And we've had those where we've gone from 60 amp to 100 amp, and that job has been 17,000.
Right.
And holy cow! Well, you're only going up 40 amps, and you're the prices. Well, the flip side of that story is the whole house was knob and tube,
Right.
and we had to go run conduit and throughout the entire house. 3 bedrooms, 2 bathrooms, basement, outdoor lighting, everything, and to get rid of all of the knob and tube, we did a couple dozen of those. Not last year, but the year before, we were doing a program. And that was running between 17 and 20,000 per house, and that's actually a pretty fair price for how much work that is.
Yeah.
That's a lot of work and a lot of material going into that. So, and that's basically your rewiring of a home. That's where it's at. I've seen rewiring go higher, but typically not. It's typically 20,000 or less.
Yeah.
And most homes don't need a complete rewire.
Yeah.
Most homes need a partial. Hey, the oldest part of the home is 80 years old and was used knob and tube when they installed it, and we just have to clear that section and repipe one area, and that can range from $2,000 to maybe $6,000 or $7,000 depending on the size.
Yeah. For general wiring upgrades, right? Say we have aluminum in that section, like you
Right.
said, in the $2,000 range. And then if you're doing a whole home rewire,
Yeah.
we're looking at a little more, up 15, 20,000, something like that for,
That's a fair number.
yeah. Okay, cool. Knob and tube also, what is that?
Well, that's
that
what I was
on?
talking about in that rewiring.
Right.
We did a lot of those knob and tube removals. We get a call too for Romex removal of the aluminum Romex. That tends to be a little more difficult because the era in which the aluminum wires were being used, homes were being insulated then. Knob and tube is in uninsulated areas only, which makes it easier for us to run pipe through walls and things like that because we're not fighting insulation. In the late 60s, early 70s, they were insulating the exterior walls of the homes and putting in aluminum Romex, which make it's significantly harder for us to swap that out.
Yeah.
So in that kind of a thing, we're typically only replacing that wire when we're actually doing a remodel. And they're opening up the walls just because they want to change everything out anyway, and then we'll repipe everything in that area. But there's like whole neighborhoods that were built. I have several that come into mind where all of the electrical in the house was all aluminum Romex, and there are more house fires in that area than any other area that I know of, and that's part of the problem is when people upgrade, like I said, they want new Decora switches or they want to put in smart switches. They're putting in switches that aren't rated for aluminum wiring, and they don't even realize what they're doing.
Right.
And they're causing big problems for themselves. So,
That all makes a lot of sense.
yeah. Anything else we're seeing in older homes that you can think of?
I think we covered a lot of it. The knob and tube,
Yeah.
the aluminum Romex, and the bonding is a really big one.
Cloth wires. We get a lot of
Cloth
questions about
wires.
cloth wires. So cloth wires, that was an insulator that was used shortly after knob and tube, but before Romex. And some of the early Romex was cloth Romex as well. People ask frequently, is that illegal? And well, usually illegal requires federal or state law be broken, and no, it's not illegal. Is it okay? And technically, yeah, unless you increase the load on those wires, they'll be fine. Right? They've been living in that wall for 80 years, and there's not really anything changing. Now, if you go plug in a supercomputer into that thing with the cooling tower and everything else, you're drawing 15 amps on that circuit, yeah, you might have a problem because that wire is now old and more brittle and not as not as thermally protected as it once was, because as that cloth deteriorates, now you have an issue of potential arcing between the hot and the neutral wires or the hot and the ground wires. But
I think one of the biggest things that changed with that was the switch to copper. right?
Yeah,
We were
definitely.
back from copper, and that's what made those outlast a lot of the knob and tube, or a lot of the aluminum
Aluminum
Romex.
Romex, yeah. Aluminum Romex was definitely short-lived.
Yeah.
And then, another thing we can talk about in older homes, and we've got one right up on the wall. I don't know if you can see it in the video there, but the Zinsco panel, center top, that panel was actually taken out of a house that the homeowner called us because they wanted to add some circuits for some sewing machines. And while there was still panel space available, I talked to the homeowner and I said, hey, you really do want to think about upgrading this panel. And, well, how much is that going to cost? Well, it's probably going to be a couple $1,000s. It wasn't an easy switch in a finished wall and a lot of moving parts. Anyway, he said, well, we don't have the budget for it right now. No problem. We'll do it when you save up for that particular project. It was less than 3 months later. I get a frantic call. I was out of state, and I get a frantic call from this woman saying, I smell some like melting plastic. And I said, okay, is it close to that panel? So she went over by the panel, and sure enough, she could see smoke coming from out of the panel. One of the circuits had overloaded. She was using a hair dryer and a curling iron and something else, all high amperage appliances, and actually melted the innards of the breaker and probably saved herself a house fire by smelling that smell and realizing what was going on. I had her turn the breaker off and turn off the hair dryer and curling iron and everything she had plugged into there. And then we got back a couple days later and upgraded that service panel. But yeah, you never know when something like that is going to happen, and that breaker should have tripped because of that load on there.
Exactly.
And it didn't. So if you have a Federal Pacific or you have a Zinsco panel or you have any of the panels that were known for causing fires, if you're concerned about it, I would get online and look up your panel, and they will tell you if there were any issues with it. Oftentimes, insurance companies notify us that they want panels swapped out. And we had a closing for it was a multi-unit apartment building. It was probably 30-unit building, and the owner was trying to sell it, and the new purchaser could not get financing because of the Zinsco panels in there.
Yep.
Their insurance company would not cover it, and therefore the bank would not finance it. So you've got some issues there with that kind of stuff. But on to our next segment. We're going to talk about DIY electrical risks. My favorite subject. Chuck in a truck who does electrical, HVAC, plumbing, wash your windows if you need, whatever that might be. That's something we see way, way, way too often.
Yep.
Is Chuck came over, and next thing you know, we're blowing breakers. Customer flips a switch and trips a breaker. We have so many instances where we've done work in a home, and typically through some of the program work we do, we'll go upgrade the panel because the utility's incentivizing people to upgrade to more efficient appliances. So we're helping them do that. We're sizing the panels properly. We're installing new circuits for heat pump dryers, heat pump water heaters, heat pump heating and cooling. And next thing you know, the homeowner calls us and says, well, when I flip the bathroom light on, the breaker trips. Well, okay, it wasn't doing that when we left, did it? No. Have you had any electrical work done? Oh, no, we haven't had anything done. And we go over there and find that all the outlets are brand new, and obviously somebody was doing something. Homeowners are electrical, please leave that to a professional.
Yep. Someone who has experience,
Right?
Electricians inspect panels and inspect systems and know how to actually do it. Just like we were talking about earlier with the right down to the outlets. The outlet you buy can be a big problem
Right.
there. I have a customer of mine who owns some commercial property. And before us, he was telling me that he was struggling to find an electrician because, like we were talking about, they're in short supply right now.
Yeah.
And someone had responded to a Craigslist ad for an
That's
electrician.
the way to find an electrician.
Exactly. And I walked into that building and it's like, okay, violation, violation, violation.
Right.
You need a lot of work here. And he's like, well, I just paid to have all this work done. Well, you didn't pay from an electrician and it's all done wrong. I'm
Yeah.
sorry. We have to go back in here and fix it. So leave it to the professionals. Call someone who is licensed, bonded.
Here's
knows what they're
fundamentally the problem with that. You'll pay for it to be done the first
Yep.
time, and then you're going to pay for it to be done right the second time. So you're going to pay twice instead of just paying once. And oftentimes, the mess we find when we get there is worse than what it would have been had we just been called out in the first place.
Yep.
In many instances, we could have saved the homeowner money had they just made the call to us first.
Yeah. And electricity is invisible, right? But the mistakes that people make can be catastrophic.
Yeah,
I
yes.
mean, house fires, electrical fires are the leading cause of house fires in the
Overheating
US.
wires.
Yep.
Yeah. Good news. Electrifying older homes is absolutely possible.
And we do it every single day, every single week at the very least.
Yeah, yeah. We can talk about different strategies. We're going to actually do a whole segment on smart panels.
Yeah,
I want to
absolutely.
do that. I think in that smart panel episode, we'll talk about load management. That's probably a good place to do that. And then, phasing the upgrades, maybe doing something a little now, something a little later.
Yeah.
That's always possible. You want to start off with a good foundation, start off with your panel, excuse me, your service upgrade, and then we can target what you want to do next, figure out what your plan is, your future, what you want to do in your home, what plans you have. Are you putting in steam showers? Are you putting in a hot tub? Are you putting in a pool, a sauna? A lot of we've had a lot of calls for saunas lately too.
Yeah.
Like, I don't know. It must be a new thing that they're doing.
Saunas and steam showers
Yeah,
are getting
yeah.
pretty big.
And both of them are big electrical draws.
Yeah.
Yeah. So, okay. Messages for homeowners.
Don't assume your house can't support electrification. There
Yep.
is almost always a way to have it done, but just make sure that you hire a professional, somebody who knows how to do it, is good at it.
Make sure they have a license. Call your local municipality and make sure that they have a license in town and that they're bonded. Some municipalities require bonding, some don't. But absolutely, you want somebody who is licensed to do work in that municipality. That means your municipality vetted them at least to the extent that they have insurance in case they burn your house down or, God forbid, fall off a ladder or whatever. They're not going to sue you. They have their own insurance. And municipalities are pretty good about making sure. I know we get letters all the time saying, oh, your insurance needs to be updated with
Yeah.
us. So we got to get a hold of the insurance agent, send over
Yeah.
a new policy. And
Check the Google reviews.
Oh.
That's one of the best ways to determine if somebody is a high quality contractor.
100%.
Is check what previous customers have to say about them.
yeah,
Because that tells the true story of what's
I've
actually going
learned that the hard way many times.
Yeah.
You think about hiring somebody, you hire them. In fact, we just had this. Somebody from our company just hired an HVAC guy to come do work, and he had a humidifier installed, and the guy who installed it did not know what he was doing. Didn't have a Google listing. Didn't have Google reviews. Brought him out onto the job and literally fried the board on the humidifier, fried the humidistat, and it just made a mess of everything. Okay, check your reviews. People will post honest reviews online. If the company didn't do a good job, don't hire them to do your work.
Exactly.
It's pretty simple. Okay, electrifying older homes means understanding older wiring, panel capacity, code upgrades, budget planning, safety risks. We can help you with any of that. I know Conrad is really well versed. We have a whole big group of electricians that are all licensed. These guys they know what they're doing. They love doing what they're doing.
Yeah.
And we can help you guys get your homes upgraded and in great condition for your future EV chargers or heat pumps or electrification upgrades. Start with that professional evaluation. It's free. Most people do it free.
Yeah.
I don't know anybody who charges for that.
I know we don't charge.
No, we don't.
And yeah, the earlier you plan these electrical upgrades, the smoother the whole process will be. As soon as and when you have the electrician out, lay out your plan. Say,
Yep.
hey, I'm thinking about adding an EV charger down the line. I'm thinking about switching to a heat pump. I'm thinking about going electric for water heating. That way, the electrician can look at it and say, oh, hey, how about we do this, this, and this? That's going to cost you less down the line, and we can get you set up in a good spot.
Yeah, whenever we go out to do an evaluation, we are always asking about future plans.
Yeah.
In fact, that's one of the sections in the code. Early on in the code, it says, part of our job as an electrician is a plan for future expansion. So we want to make sure you're set up for success. Everything is continuing to go electric. Definitely don't wait on this.
Yeah.
Today is the day it's going to cost you the least amount of money to make these upgrades. And yeah, the only cheaper day was yesterday. So everything continues to go up in cost as we see fluctuation in the copper prices. That has a big impact on our pricing.
Yeah.
Because that's our direct materials. As we see steel go up, as we see
It's everything.
Today's the cheapest day to get it done. So definitely don't waste any time. Give us a call. We want to take a look at your system. We want to make sure you're up to grade and up to speed. No issues. And I think that's a wrap. Thanks, Conrad. Appreciate you joining me. Once again, thanks for tuning in to Plugged In with Eco Energy, and we'll see you next week.